at Stanford University.
All right, well, welcome to lecture number 9 of CS193P, fall 2013-14. Today I'm going to finish the animation demo that we started on Monday, and then the lecture is going to be about auto layout, which is a really cool system for making it so that your user interface can adapt to changing conditions. And then I'll do a brief auto layout demo at the end, just so you can kind of see it in action. Seeing is believing, especially with auto layout. So this demo, where we left off is the blocks would come down due to gravity and they would collide at the bottom and they'd kind of run into each other. And then when a bottom row was full, they would all kind of fly off into outer space. And I think where we left off too is they would stack up and they weren't flying off. Okay, and so why weren't they flying off at the end? Well, part of the reason they weren't flying off was because those towers of blocks were so tippy. They were kind of wiggling and they were never coming to rest. Okay, so they were never, the animation was never stopping. It was always continuing to move them a little bit. And so we're going to start off our demo by making those stacks a little more solid, a little less tippy, by making it so that the blocks can't rotate. So since they can't rotate, they'll sit on top of each other much nicer. And I'm going to turn gravity back up to 1.0. I think I typed in 0.9 at some point, just as part of the demo, but let's crank it back up so that they will sit a little bit so they don't float at all, you know, so they sit down strongly on top of each other. Then what I'm going to do is use an attachment behavior so that as a block falls, we can grab onto it. Okay? And then we can kind of swing it around and pick which stack we want to drop it in and then let it go. And then the last thing I'm going to do is we're going to use the action block of that attachment behavior to animate that and show the attachment. I'm just going to actually draw a little line to show it. So there's quite a bit to show there. I don't think we're going to have time to do this collision delegate thing, but I'll post the code for that so you can see what that's all about. All right, so let's get back over to Xcode here and go back into drop it. And okay, so remember that we moved all of the behavior of this thing out into its own subclass of UI dynamic behavior called drop it behavior right over here, this guy. And so that's where the gravity and the collision is. And so what I'm going to do there is I'm going to add another behavior to that custom behavior, which lets us control things like whether the blocks rotate. Okay? We could also control friction, resistance, density, those kind of things in there. The kind of behavior that controls those things is called a UI dynamic item behavior, because it's specifying the behavior of that item. Okay? So we'll call that maybe something like animation options or something like that. You could call them item behaviors. You might call them physical characteristics almost, but we'll do that. And let's go down here and lazy instantiate that. So dynamic behavior, animation options. If not animation options, then animation options equals UI dynamic item behavior alloc init. So I'm just allocating this thing. And I'm going to allow rotation, no. So I'm not going to allow these items to rotate. Okay, so the blocks will have to stay, as they bounce on each other and collide, they'll have to stay non-rotated. All right, and return animation options. And again, we could do other things in here like dot friction equals, dot density equals, whatever, but we'll keep this simple. I obviously want all items to be added also to this animation adoption thing, and we clearly want to remove all items as well. And let's finally add our child behavior, animation options. So the animation options act like any other behavior, okay? They just specify attributes instead of, you know, applying the forces or whatever. But you can actually think of them somewhat as applying forces too. It's just, you know, like forces to keep them from rotating or forces to make them have higher friction, those kind of things. Okay, question?
If they conflict, do
being resolved like forces?
What a great question. You mean if you had multiple item behaviors that had different conflicting densities or whatever? So that's a great question. There are rules for that. If you have a tree of behaviors and you had some item behaviors in there, there are rules for which one wins. It's kind of the last one wins, and how that happens is all defined in the documentation for it. So if you're going to build a tree so complicated that you have the items in there twice with two different behaviors and different things, I mean, that's pretty, I mean, if you're doing that, you really got to know what you're doing. And so you really want to read the documentation. That would be considered advanced behavior to do that. But it can be done. It is legal. OK, so now we'll have that. So now when we run this, we'll get a little less of the tippy stack thing, although I didn't change the gravity, but we'll see what happens here. But you can see they're definitely not twisting. They're staying. They still might bounce slightly to the side if they, for example, if I click too fast, they might crash into each other on the way down, ones that are in the same column. So here we go. So now they're going to be flying away a little more reliably. Let's try going really fast, see if we can get them to tip a little. Now, if I have multiple rows, they should all go together. Notice also I'm starting to get a lot of blocks, and the performance is starting to get a little jerky, okay? And that's something you have to understand with animation. If you have a lot of things animated, it's not free, okay? Animation is not free. And if you had an application like this where you were dropping these blocks and you allowed the user to drop a lot of them, you might have to start doing some other things. Like, for example, instead of having the collision boundary, instead of having all the items collide with each other, what if you just drew a boundary around the top that the top ones could collide to? You see? Then you would keep all those bottom ones from having to calculate where they're going to go, because you'll notice that after they get tamped down a little bit, they don't bounce so much at the bottom anyway. So you could take away that bounce and put a boundary, because your boundary is a UI Bezier path, could be anything you want. Okay? So you have to think about that only, when you start to get to extreme cases there. Okay, everyone cool with that? Make sense? All right, so the last thing we're going to do is this attachment behavior. So this is just attaching that bar, which can be a springy bar or an iron bar. I'm going to leave mine be an iron bar, a bar that doesn't collapse and expand. And we will use that bar to grab onto one that's coming down so I can swing it into the right column. Because right now, it's just whatever column it comes down in, that's the column it goes in, and that's a little bit restrictive. It makes it hard for my game to play very, very competitively. And so what we're going to do this, we need a couple of things here in our view controller. One is we're going to clearly need an attachment behavior. So I'm going to create a new UI attachment behavior. I'm just going to call it attachment. Okay. And I'm also going to need to know which view is dropping. Okay. The view that's currently falling down, because that's the one I'm going to grab on. Because there's a whole bunch of views in my game, right? Tons of them all over, stacked up there. Which one, when I start grabbing, am I going to grab onto? It's going to be the dropping view. So I'm going to have to keep track of the dropping view. And in fact, that's easy to keep track of. I'll just write down here, every time I drop a new one, I'm going to say the dropping view equals the drop view. Okay, so every time a new one comes down, it's going to become the one that gets grabbed. So if I have multiple of them coming down at once, it's the last one that started coming down is going to be the one that gets grabbed if I grab onto it with this attachment. Okay, so now I have the dropping view. So I'm going to do the attachment with a pan gesture. Okay, so we're going to see another gesture recognizer here because I'm going to grab it, and then as I move my finger around on the screen, I'm going to keep the attachment attached to my finger. So the block that's being grabbed onto with the attachment, it will kind of follow my finger around, right, with a bar behind it. So that'll be kind of fun. So let's do that. So you remember the gestures we set up, right, from our storyboard, right? Here's a storyboard. I'm going to go over here and grab a gesture. It's a pan gesture, which means follow the finger around. So here's a pan gesture. Drag this out. I'm just going to drag it on top of my game view, right on top here. Here's my tap gesture. Here's my pan gesture. So I'm going to drag it out. I'm going to put it down near where my tap gesture is. Here's my tap gesture right here. So I'm going to put my pan gesture right next to it. I'm going to call it pan. I'm probably teaching a bad style here to call these pan and tap. I call them that so that when you see them, you realize, oh yeah, that's the pan gesture handler. But again, this could be something like grab drop. That might be a better name for this than pan, okay? So there's our gesture. And let's make some more space. And actually, we don't even need to see, actually, let's go back here. We don't need to see our storyboard for this. Okay, so I've got my pan right here. So what's going to happen in this pan? Okay, pan gestures like pinch gestures and continuous gestures like that, they kind of have a similar sequence of events that goes on. So I have a little snippet that I do the same thing for all these kind of gestures, which is they start out, they begin, then they change as they move around, and then they end. So what are the three things we're going to do for our pan gesture when we do our attachment? Well, the first thing I'm going to do, actually the first thing I'm going to do is I'm going to find out where is that pan gesture? Where did that happen in my game view? And I'm going to do that with CG point, gesture point equals sender location in view, my game view. Okay, so now I know where in my game view that happened. So this is a gesture recognizer, right? The sender is, and this is a method in pan gesture recognizer, which tells you the location the pan happened, or is happening if it's moving around. It tells you the new position. So the first thing I'm going to do is I'm going to attach the dropping view, that thing we just said, to that point, the gesture point. Okay, so this is a method we're going to have to write. So I'll put it down here so that we remember to do it. Although we might remember better if we don't put this down here, but because they keep complaining, we'll do that. So I'm going to have this attached to dropping view. That's going to be the guts of doing an attachment thing. Here, when the pan changes, when it moves to a new spot, I'm just going to have my attachment behavior anchor point. Okay, anchor point, remember, the attachment can be either attachment between two items or between an anchor point and an item. This is going to be between an anchor point. That anchor point is going to be following my finger around. I'm going to set that to be the gesture point. Okay, so that's all I'm going to do when it changes. And then when it's done, I'm going to remove this attachment, remove behavior, this attachment from my animator. So my animator is going to stop doing that animation anymore. Okay? So that's it. You can see this is all pretty easy to do, all of this stuff. Even this attach is going to be really straightforward. So let's look at that attach. How do we create an attachment behavior between an anchor point and some item? And it's very simple. If we have an item that's currently dropping, okay, hopefully we do, then we're just going to create a new attachment behavior with UI attachment behavior, alloc, and it's init. It has, remember, 4 different kinds of inits here, depending on whether you're attaching to points or between two items. It also has some ways to attach with an offset so that the iron bar is not connected to the center of the thing. Maybe it's centered a little offset. It'll kind of tilt a little bit. So I'm going to do the one which is init with item attached to anchor, which is this one, I guess. Yeah. And the item is going to be that dropping view. Oops, sorry, attached to item. No, I wanted a different one. I want attached to anchor. And the anchor is going to be that point, right, where my pan gesture went down. So that's it. It's as simple as that. Now I have an attachment between that point and this dropping view. I'm going to be moving that point as the gesture moves, and the dropping view is just going to follow around. After that attachment happens, by the way, I'm not going to allow you to do it again, so I'm going to set the dropping view to nil. Okay? Because in other words, I'm not going to let you grab onto that thing, move it a little, oops, grab onto it again, move it again. Nope, you get one try. Okay, that's just part of the gameplay. I only want you to get one try at dropping that thing. And then I just say animator, add behavior, and the instant I do this, it's going to start animating that. Okay, animating an anchor, a connection between that point and that view. Okay, so I think that's all I have to do. Yeah, so let's run and see if this works.